everybody. Today we're going to learn about the difference between dissolving and dissociating. Covalent compounds, and we learned about those in an earlier video, would be something like oxygen that I have drawn right here. So this is a bubble of oxygen in a container or a tube or something. And you see that the molecules are made of two oxygen atoms, and those oxygen atoms are touching. They're bonded together into a molecule. Well, you guys should know, hopefully, that oxygen will dissolve in water. Think about a fish tank. You've all probably seen an aquarium that has a bubbler that's sending little air bubbles through the water. And most of you probably know that fish need to breathe oxygen out of the water. They get oxygen out of the water through their lungs. Well, if they're getting oxygen out of the water, that must mean that it is oxygen dissolved in the water. So let's put this bubble of oxygen into water. The blue are water molecules, all right? Water molecules really do look kind of like a Mickey Mouse head. And then the black, again, is the same as we had before. We have some covalently bonded oxygen molecules. And you'll see that the oxygen molecules, they're not all clumped together. The oxygen molecules have separated from each other and they've spread throughout the water. But each pair of oxygen atoms is still bonded together in a molecule. We have this molecule separate from this molecule, but it's still a molecule. It's still a pair of oxygen atoms. This is what we call dissolving. You might also come across the word dissolution, which is the act of dissolving. So that's a word you might see. This is something that occurs with covalent compounds. Ionic compounds do something different. So let's say that we have sodium chloride here. We have some salt crystals. And just like we drew in a previous video, we have alternating cations and anions. We have alternating positive and negative charges, making kind of a checkerboard pattern here. When we take that salt crystal and we put it into water, they separate out completely. We now have positive ions surrounded by water and negative ions surrounded by water. We don't have a positive sodium and a negative chloride together. They've completely separated. So they're not only separate from the crystal of salt, but they're separate from each other. This is what we call dissociation. We say that it dissociates. And there's another thing you need to be careful of. So we have our positive sodium cation here, and it is surrounded by water molecules. Do you see that I drew the water molecules so that the oxygens are all facing that positive sodium? That's because the oxygen part of water is the partially negative part. We talked about that during the polar and nonpolar covalent video, so you might want to go back and look at that. So the oxygen is the negative part of the water. The negative part of the water is attracted to the positive sodium cation. When we come over here and look at our negative chloride ion, we see that the water molecules have flipped. They're bigger. I didn't mean to draw them bigger. That was just an accident. So the size isn't the important thing. It's the fact that the water molecules have flipped the opposite way. Now the positive hydrogen end of the water molecule is facing the negative chloride ion. The positives are attracted to negatives, and the negatives are attracted to positives. So again, when we're discussing dissolving versus dissociating, covalent bonds will dissolve. Ionic bonds completely dissociate. That's why if you try and conduct electricity through solid salt, it won't happen. These cations and anions, they're locked into place. All right, so no electrical charges can flow. But when you take salt and you dissolve it in water, now these water molecules and these anions and cations, they can flow and move around. So a charge can move from one place to another. Because ionic bonds dissociate, they can conduct electricity. That can become important, so we're going to write this down. They conduct electricity as a solution, not as a solid. Covalent bonds, we don't have any charges. You don't see positive or negative anywhere. So covalent molecules that are dissolved do not conduct electricity in solution. Again, it may be helpful for you to pause this video and draw this so that's something you can have in your notes. Either way, I hope this helps. Thank you.